This is the MIG-25. It flew at Mach 2.8 as maximum operational speed, but its engines were so powerful that they could reach Mach 3.2. In other words, at 372 miles h, you could cross the entire Soviet Union in just 2 hours. It was made to intercept the American supersonic bombers of the Cold War, which could reach similar speeds. And yes, it was possible to eject at its maximum operational speed. But how is this possible? If a person were to just exit their plane at that speed, wouldn't they have to die instantly? Today we will see how it was possible to eject at such speed. We will see the consequences of ejecting at that speed. And why not? We will also learn a little more about the history of the fastest interceptors in history. So get comfortable and welcome to Guns Club. In the Cold War, the Soviet Union and the United States were in a constant engineering war to always be at the forefront of technology compared to the other. This made the late 20th century the period of the greatest aeronautical progress in history. Both nations had weapons capable of annihilating the other with ease. The problem was how you transported those weapons to the enemy and how you nullified those forms of transport to defend yourself. By the late 50s, the Americans would seek to make bombers that surpassed air defenses and Soviet interceptors. The engineers' solution was to directly make bombers faster, so fast that they would have to break the speed of sound several times. By the time the 60s began, they could already exceed Mach 2, and they were making models faster and faster. So much so that missiles and interceptors had trouble reaching them. Likewise, the Soviet government would submit a formal request to Mikoyan-Gurevich for the design of an interceptor capable of reaching Mach 2. It had a flight ceiling of 2,543 yards, and it also had to have cutting-edge technology, radars, flight computers, and current missiles. And of course, the most important thing, it had to be mass-produced, so it had to be very cheap, both to produce and to repair. The main obstacle was the lack of engines in the Soviet Union capable of reliably flying at such high speeds. Starting an engine like that from scratch would take years, so the engineers would look at the Tu-121, an experimental intercontinental cruise missile that had what they were looking for. An engine that exceeded Mach 3. It used the KR-15 engine, which could easily exceed Mach 3, but had a lifespan of only 15 hours. This was fine for a cruise missile, but it was no good for an airplane. They had to spend an entire year modifying the engine to extend its lifespan to 500 flight hours just by reducing the thrust a little bit. Thus was born the R-15B300. Now that they had the engine, they could design the airplane from it. Initially, the fuselage resembled an enlarged MiG-21. This was very useful to make it much easier to produce. But during the development of the plane, the Soviets shot down an American U-2 reconnaissance plane, causing a worldwide shock. The Soviet Union took no pride in shooting down the U-2 after it had covered nearly half the country. The interceptors of the time chased it for hours, unable to do anything to it. It was clear that the Americans were massively spying on the Soviet Union and they couldn't do anything about it. This made the new interceptor imperative. So the Soviet government allocated much more budget to the project. Now the engineers had a lot more money to better design the fuselage, so the fuselage went from this to this. Likewise, in 1970, the MIG-25 was introduced for use in the Air Force and in mass production. This was a whole new chapter in aeronautical design. It was, without a doubt, the fastest plane in the world, and it would be until the Americans brought out the Strategic Reconnaissance 71. It could fly at Mach 2.8, this as maximum operational speed, and at Mach 3.2 if required. This speed would have a significant impact on the engine's lifespan, so it could only fly at this speed in emergencies. The R-515, B-300 engines were huge. The two engines of the plane were so tight that their nozzles overlapped. But thanks to these two, the plane was so fast that if the wind hit the turbine blades directly, they would explode without further ado. Because of this, it had a turbulator in the center of the huge intake nozzles to slow down the air and compress it. It was so fast that if it were made of an aluminum alloy, like conventional airplanes, it would melt in the air. For this reason, its fuselage was made of steel. which made it the heaviest interceptor in the world, but also made it very cheap to produce. Additionally, to reduce its temperature, it used a coolant called Mazantra, which was basically alcohol diluted in water. And if you had a healthy liver, you could even drink it as if it were vodka. If you translated, Mazantra in its acronym said Mikoyan Artyop, glorious son of the Armenian people who brings joy to its aviators. And rightly so, because every MIG-25 had 180 liters of Mazantra. So if you crashed in the forest, you wouldn't be short of alcohol. But it was so fast, so much so that if you weren't made of steel, you would melt. How was it possible to inject Mach 3? The secret was in a combination of suit, height, and its advanced injection system at the wing of the injection handle. Between the legs, the grip straps tightened, tying the pilot tightly to the chair. Then the pilot's suit pressurizes and the chair begins to autonomously take care of the energy supply and feed oxygen into the suit. Then the rocket starts, separating the windshield and throwing the pilot down a rail. The chair makes a parabola backwards in relation to the direction of the plane, so that in this way the speed at which they were going is counteracted. Subsequently, when the rockets ran out of fuel, the parachutes should already be activated to stop the fall, and in this way the chair would stabilize. The key to the pilot's survival was in his BKK suit, and also in the height at which he ejected. The BKK suit. It's a pressurized suit for high-altitude missions, which could withstand pressure and temperature. It was similar to the suits that astronauts used to go into Earth's orbit. This, along with the rocket, whose trajectory ensures that the chair makes a slow and progressive deceleration. It allows the pilot to withstand the harsh impact of ejecting at over 3,500 kilometers per hour. In a similar way, the pilots of the SR-71 could eject safely. Their suits allowed them to withstand the speed of Mach 3, 0.2, and even Mach 3, 0.5, and in 50 seconds, be descending at zero speed to the ground. As I said, the suits were key. They allowed them to breathe and withstand the relatively high temperatures due to friction and the subsequent low temperatures due to altitude. But more than anything, it was safe to eject at that speed, specifically because of the height at which they did it. The higher the altitude, the less pressure there is. So when ejecting at 24,000 meters at a Mach 3 ejection would feel like ejecting at 195 miles h at sea level. At that height, the conditions are close to being in space. Because of this, the initial impact when leaving the plane is quite low compared to what you would receive at sea level. So ejecting at Mach 3 at that height is very safe. I know what you're thinking. And what happens if I eject at Mach 3 at sea level? Well, you would directly die from the gust of wind received the instant you get out. Stop. To eject at that speed, you would need an ejection capsule similar to the XB-70 Valkyr. Either way, the MiG-2531 and the Strategic Reconnaissance 71 could only reach Mach 3 at medium and high altitudes. At really low altitudes, where the pressure is stronger, the maximum speed of these planes used to be around 1,400 kilometers per hour, or almost Mach 1. And ejecting at that speed is still very safe, so in fact you could eject at any speed. The point is, at what altitude do you eject? If you enjoyed this video, you might be curious about the odd bump present on the nose of Soviet, Chinese, Korean, and European planes. Thanks for watching. See you next time. Goodbye.